All right, let's look at another example. And here I've got sine of x divided by 2. So that's going to tell me I need to use a half angle identity. Plus cosine x minus 1 equals 0. And I want the answers between 0 and 2 pi. All right, so let's do this. I know that sine of x divided by 2 is going to be plus or minus the square root of 1 minus cosine x over 2. Now I have my plus cosine x minus 1 equals 0. Really, this is two different equations. We have the plus or minus. What's really nice about this is when you solve the plus and the minus, you end up with the exact same thing. So it's pretty nice on that aspect. So I'm just going to solve the plus side here. I'm going to subtract my cosine, add my 1. So I'm going to get the square root of 1 minus cosine x divided by 2. Equals 1 minus cosine x. I'm going to square both sides. I get 1 minus cosine x divided by 2 equals 1 minus 2 cosine x plus cosine squared x. Remember that when you square this, you have to FOIL it. So we're really doing this 1 minus cosine x squared. So you have to FOIL it. That's where I get this from. Multiply both sides by 2. I get 1 minus cosine x equals 2 minus 4 cosine x plus 2 cosine squared x. Move everything to one side because it's going to be a quadratic that factors. I'm going to get 0 equals 2 cosine squared x minus 3 cosine x plus 1. This does factor. Sorry about that. The 0, this factors 2 cosine x minus 1 and cosine x minus 1. Yeah, minus 1. We set them both equal to 0. We get cosine x, or 2 cosine x minus 1 equals 0, which turns into cosine x equals 1/2. And cosine x minus 1 equals 0, which gives me cosine x equals, let's say that's 1. These are on your unit circle. Cosine x at is 1/2 at pi over 3 and 5 pi over 3. And let's see, cosine is 1 at just simply 0. So now we have to be careful with this. If you remember from Algebra 2, when I'm solving square roots, and I square both sides, and I get answers, I have to go back and plug these into the original equation and check for extraneous solutions. Because just because we get an answer here doesn't mean it's an actual answer to the equation. Remember, the extraneous solution means mathematically it works out, but it doesn't work out in the original problem. So we need to go ahead and check these. So let's pull up a calculator and check. Anytime you square something, you're introducing something in, you're going to have to check for extraneous solutions. So what I've already done is I have went ahead and put this in my y equals sine of x divided by 2 plus cosine x minus 1. And I'm going to go to my table. And I have my table, if I go to my table set, I have my independent on ask, so I can actually type in my numbers, which makes my life a lot easier. I'm going to go to table, and let's just go up to the top here. You can see I already checked it. So I'm going to do second pi divided by 3, because that's one of my answers. And if I'm in the right mode, which I am going to be, I need to be in radian mode, I get 0. Voila. Now I'm going to do 5 pi over 3. I'm going to do 5 pi, that's e, not pi, pi divided by 3. And if that is the solution, it'll be 0. Voila. So 5 pi over 3 equals 0. Good enough. Now I just need to simply check 0, which I already have here. But I just plug in 0, hit enter, and I get 0. Voila, 0 works. So all three of these are solutions to this. So my solution set is going to be x equals 0, pi over 3, and 5 pi over 3. Just remember, the only reason why I checked this one for extraneous solutions is because I squared right here. If I didn't square there, I don't really need to check for extraneous solutions. But because I squared it, I need to check for extraneous solutions. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students.
If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.